Well, hello C++ programmers and fellow game developers. Brian Malloy here, and this is part 2 in a two-part sequence about explosions. And this video is going to focus on how to incorporate an explosion into an object-oriented framework. So here is, excuse me, just to review part 1. In part 1 we described how we can create an explosion using really these two classes derived from sprite. So we have a chunk, which is really just a sprite. So if you recall, let me just bring up the video. Here it is. And so let's just make an explosion just to review. Let me see. Can I do the blue one or the green one? I'll do the green one. That wasn't the green one. Let me try to get the green one. There's the green one. Okay, so how do we do that? And essentially, you recall in fact, let me see if I can pause it, right? So there we go. And you can see it's starting to split up. So you kind of grid it. So you carve it this way, and get all these little sprites, okay? All these. So you take one big sprite and you make a whole bunch of little sprites, and then we disperse them, and then they have a lifetime. Okay, so there we go. So that's a chunk. And as an exploding sprite is an aggregation of chunks, and they all behave like sprites because we draw them and we update them. So this is kind of the that end of the explosion. This was part 1. So what I want to talk about next is how I incorporate an explosion into this framework. And if you recall our framework, let me just get out of this one. And our framework, actually, I think we can just to show you the complete framework. I've got it here somewhere. Let me go to your place. I think I put it in here. Okay, so if oh boy, sorry. And so I'm getting it up here. It's coming. Okay, so there it should be there, and we can look at the class diagram. Okay, so I don't know how much of that you can see, but this is the whole framework. You're probably not seeing very much of it, but how do we incorporate an explosion into these 13 classes? And the answer is pretty straightforward, actually. Here's sprite. We can just copy, actually, the exploding sprite and the chunk into our directory, and they'll automatically get the reuse that we have already incorporated there. But how do we actually get it working? So here's how. Let me start off by, I want to talk before I go into that. I want to talk about inheritance a little bit. So let me just show you. Here's a, you can hear that it's 9 o'clock at my house. Sorry about that. I guess we should just wait, right? So here we have a shape class. Class called shape. And it's an abstract base class with a pure virtual function area. And I have two derived classes, circle and rectangle. Okay, and we want to program to an interface when we have a polymorphic collection. So this is a polymorphic vector. Why? Well, because we have a pointer to the base class, and into this list of shapes we can put either a circle or a rectangle or literally anything in the inheritance hierarchy, which is actually only circle and rectangle. Now, and then we can call this little thing print area shapes. And we can come up here, we can print the area of each one of these shapes that we have in here. So let me just go ahead and compile this, and let me run it, and you'll see that we get those areas that we talked about earlier. So there we go. Why am I doing this? Well, I want to point out to you that if we put something in here for circle, let's suppose we've got this get radius, which I already put in here. So I have a function called get radius. And I happen to know that shapes of 0 is a circle. So shapes of 0, in fact, we got that right there, 78.5 when I printed that. Can I call get radius? And the answer is a resounding no. So this will not compile. Let me just clear the screen and show you that one, no member named get radius in shape. Now, why is it looking at shape? We all know that shapes of 0 is a circle. Well, the important thing to understand here is how the C++ compiler looks for excuse me, a function when we call it. So we have shapes of 0 get radius. So the compiler says, okay, these are all pointers to shape. So it goes to shape then and looks for a get radius. There isn't one. Okay, there is no get radius up here. So what you see here is that's what it says, error, no member named get radius in shape. So that's the problem. This is a common problem in object-oriented development, and that's why the rule is program to an interface, not an implementation. What does that mean? Well, circle is an implementation of a shape, a specific, specialized implementation of a shape. It's a circle, as is rectangle. But we want to program to the interface for the base class. Well, we can't. How do we get out of this problem? Well, one way is to put a function here, virtual, let's see, I guess it'll be a float, get radius, and const, and we'll put in there throw std : string. Oops, we'll just put that. Okay, and what does that mean? That means if we happen to try to get the radius of a rectangle, that will get this error message. All right, now you might not like that way. There are other ways to resolve this problem, but it's a common problem. And what you're thinking right now as you see this is that it doesn't make sense. Most shapes don't have a radius. So there are other ways around it. This is the approach I'm going to use when we come up with this problem, when we try to incorporate explosions into our framework. So if I compile this now, you'll see that it compiles and it runs, and we get the radius is 5. So we have to program to an interface. What's the interface? The interface is the base class, because this is a polymorphic list of shapes. So you might not like that solution. You might want to look in Myers. He talks about this specific problem with regards to birds, and birds flying. Robins fly, but penguins don't, or something like that. What do you do when you have an inheritance hierarchy like that? It's a common problem. I'm not going to give you all the solutions right here. I just want to mention this as one of the solutions. Okay, so that's that. Let's get rid of this and come over here. So if you recall, our drawable before did not have an explode in it. So before we go to drawable, let me go to the manager and explain what's happening and how do we get an explosion. Well, let me just give you the general idea. When I hit the 0 key, I tell sprites of 0 to explode. So that's the OO way. Okay, we say, hey, go do this. So you're a sprite, you ought to be able to draw yourself, you ought to be able to update yourself, and I'd like you to explode yourself. It doesn't sound very nice, but nevertheless, it's what I want. If I hit the 1 key, I want sprites of 1 to explode, him or herself, similarly with 2. Okay? We tell them to go explode. Now, what are we telling to explode? We're telling, let me just split this up into manager.h. We have here a polymorphic list of drawable star. So we're telling a drawable to explode. So based on what I just showed you about shapes, that means that somewhere up here, if this is going to work, I have to put an explode. So there's what I did. And I put a virtual void explode so that really basically what I'm saying is anything in any drawable should be able to explode itself. And you know, that's the way games are now. You can shoot something and it explodes. That's what we want. If we shoot a door, we want it to blow up so we can go through it. If we shoot another NPC or an enemy, we want them to explode. We really like to see explosions. It's embarrassing, but true. Okay, so first of all, I need to put an explode into my base class drawable because I have in manager a list of drawable star or a vector of drawable star. So if I want to tell a sprite to explode itself, I have to put an explode in the base class. Okay? Now, next I have a sprite. I want to show you the sprite and what we tell it because we're actually almost closing in on, did I do this backwards? Yes. I want to say : split sprite .h. Okay, here's sprite. So there are a couple things going on here, and I want to familiarize you with all of them. So first of all, you'll see this forward declare. Why? Well, because I want a sprite to be able to explode itself. Now, this is the way I solved it. You might be able to come up with something better, and I hope you do. Go for it. But I'm going to show you how I wanted to do it. So one of the data attributes of sprites is that they can contain an explosion. In fact, they can take on the form of an explosion. So how do we do that? Well, we tell them to explode. Right here we say to the sprite, hey, go explode. I'm sick of you. Go explode. Okay, and the way I've set this explosion up is that when the explosion is done, when the explosion is finished, I want the sprite to reappear. Let me show you that. So if I run this, you'll notice, let me blow up this this green. Okay, there goes the green thing. Now, as soon as the explosion is done, that is, all these sprite pieces have gone the distance. Once they've gone the distance, you'll notice that that green sprite reappears. There it goes. Now, that's the way I've programmed this. You might want to program it so that when the explosion is finished, you might want to put them into delete them from the list or do whatever you want. But that's the way I've programmed this. So after the explosion is done, I make them reappear. And it's real easy to do. So let's just talk about what happens in explode, and then we're just about there. Okay, so here's explode. Well, that's easy. If it's already exploding, so if explosion is already happening, forget it. You can't make it explode. So in other words, what we're saying is, let me just let's show you this green one. When a green one gets over something, I'll try to make, okay, I'm exploding. Now I'm still hitting the 2. Can you hear me hit the, I'm hitting the 2 key, but nothing will happen. So in other words, if I keep hitting 2 and I keep telling it to explode, it's going to come over here and say, well, you turkey, it's already exploding. Forget it. All right. So, but if, wait a minute, where am I? I'm sorry, up here. So if I try to tell it to explode and it's already exploding, we go back there. Otherwise, otherwise, if it's not exploding, I want it to explode. So I set explosion equal to a new exploding sprite, passing this sprite in because I want to use everything about this sprite to do the explosion. Everything about it means its texture, you know, the image, the sprite image that we have, and its position, its velocity. I want to incorporate all of that into the explosion. And in part 1, I tried to talk about how we do that. All right, now let's look at the update. And here's where it might be you think a little hokey. You can change it. So when I update, now whenever so drawing, let's look at draw. That's easier. If I have an explosion, I tell the explosion to draw itself. Okay? Otherwise, I tell the frame to draw at XY. All right? So that's pretty straightforward. If I have an explosion currently going on, tell the explosion to draw, otherwise draw the frame. Now there are other ways to do this. I'm just showing you one kind of quick way. All right, let's look at the update. If I have an explosion, tell the explosion to update, and then I want to check the count. If the chunk count is 0, that means there's no more chunks being dispersed. That means the explosion is finished. So I'm actually deleting the explosion and setting it to null for the next time in case we want to explode it again. You might want to do other things like set a flag so that the manager can say, okay, you're done exploding, we're going to get rid of you, or whatever. Or I could save the explosion the first time and reuse it if I want to keep exploding. All I have to do is change the position. So I could have done that. There are lots of things I could have done. But basically that's what I'm going to do. If it's exploding, update the explosion, check to see if it's done. If it's done, get rid of it and set explosion to null. And if explosion is null, I won't come into this if. If there's no explosion, I simply want to update as usual. I wonder why I didn't call the update from above. Why didn't I just call, oh, because this is it. We are in the above. Okay, sorry. I thought we were derived from something. And that's it. Basically, that's the story. I tell a sprite to go explode itself, and this is the way I've chosen to go tell it to go explode itself. And what I have here is everything, all of the data attributes of this sprite are right here. I don't have, if I were going to try to choreograph this explosion in the manager class, I'd have to go get its position and go get its frame, and it's an ugly thing. This is the way I've chosen to do it. Think about it. If you want to come up with a better way to do it, I'm real interested. Send me an email and let me know how you're doing. At any rate, thanks for listening. Happy programming. Brian Malloy, over and out.